Welcome to another CO2 Monday. I'm your host, Trevor Matthews, and today I have a special guest, Manuel Fröschle from BOCK Compressors. I'm really excited about this conversation because I don't really know a lot about BOCK compressors. I did a session on compressors back in October about CO2 compressors that I found from around the world, and BOCK was one of them. And I got into their the VAP or VAP software, and I thought it was really cool. And then I was able to start looking at some of their documents, but I didn't really spend a lot of time learning about Bach. From my understanding, they're a real big player in the CO2 market in Europe. And I really wanted to have this conversation because Manuel is an expert in CO2. He's been doing it for many, many years. And this is what this CO2 Monday is all about, is learning about CO2, learning about the top manufacturers, top experts, technicians in this industry. So Manuel, welcome to CO2 Mondays. How you doing?
Good morning, good afternoon around the world. Thank you, Trevor, to have me here in the CO2 Monday call, and it's a very big pleasure for me to give the or to get the possibility to participate in that nice conversation.
I
Thank
really
you.
appreciate it. I do really appreciate you taking the time to do this. Why don't we start about your background in CO2, a little bit about yourself and where how you got to where you are today.
Yeah, I'm here at BOCK at the moment, or for today. I'm responsible for the application side, for the technical side, for the sales support on the technical side, and I also have the role of a product manager for natural refrigerants. That means, of course, CO2, what we would like to discuss today, but it means also for us, we have a product line for hydrocarbon compressors, so for flammable gases, which is also very popular in the chiller and heat pump market and in other refrigerations. But for CO2, it's of course for me a longer history. Also, I'm started more or less with directly with CO2 in the refrigeration business. Because I started my career in the automotive industry, and then I decided, okay, during my study that thermodynamic is a very interesting field of and refrigeration was the chance to do that in the university. I started here in Germany to work with or put the focus on refrigeration and heat pump and air conditioning. And that was a big or a nice thing to see how interesting refrigeration is, of course. And during my university, I had a chance to do an work in abroad in Norway. So I was there for some months in Trondheim, and maybe you know in Trondheim there are also it's very popular city for CO2 because Gustav Lorentzen also bring in or invited to the CO2 back to the refrigeration world, and there I could learn during my practical year there during the university. I could work already with CO2 in different applications. I had the chance to work with different components with CO2 compressor already, but also with ejector systems, and I learned a little bit the system behind CO2, and it was a really exciting time to see what is possible with CO2, and I recognize really, okay, that's an interesting field, and I would like to focus on that. And that was also then later I could work with the systems around CO2. That was in 2007. It was quite early in the beginning of CO2 here in Europe. Also, of course, were already some installations, but not CO2 was not so popular like it is, of course, today in Europe. And it was a really exciting time. And I had also here in BOCK in this time, we started with, or BOCK had already some CO2 compressors, but it was also the time where CO2 compressors were developed, the second generation of CO2 compressors. And it was, of course, for me, a very big chance to work with the experts here in BOCK with the know-how what they had already built up from the beginning of the 90s.
Oh,
And yeah,
that's awesome. So back in 2007, this is kind of when it really you start to see a bit more of it, you start to get involved. How has it changed? Like what was it back in 2007 with your compressors testing it for, I'm assuming, for CO2, and then now as it evolved, we're 15 years in it. How is it different? And because you did a lot of the training as well for your customers, right?
yes.
That was one of your roles previous roles is teaching your customers about CO2, about your compressors. Let's talk about like the bit about the history of BOCK and that rollout to where you are today with the Star CO2 compressor that I actually found a couple weeks ago.
Yeah, I think maybe everybody who knows maybe BOCK not so well, we are very old company. We have 90 years anniversary
Wow.
this year, so that's we are producing since 90 years mainly piston compressors, and today we are producing only we focusing on piston on reciprocating compressors. And yeah, that's a long history. I think for CO2 it's not that long the history, but even here we have close to 30 years of history with CO2. So we started in 1993 that with a first compressor. It was really in the beginning, and the people are maybe a little bit nervous in the beginning with the high pressure to start these technologies. Of course, that was really an exciting time. I think I was not here, but what I heard and what I get here also from the colleagues and from the history, of course. But I think it was quite early for CO2 in the beginning of 19th. It was important time, I think, to develop CO2 in the right direction, to give the possibility to have components, because that was really the biggest issue in the beginning, to get the components for the high pressure. We started in the beginning also with open type compressors. This is something what we completely stopped. We focusing now only on semi-hermetics or closed semi-hermetics compressors. So but in this time, it was important to have components, to have a compressor, to testing CO2 in the different configuration, to see what is going on in the system, how we can control CO2, how we can work with CO2, how it is with the high pressure, with transcritical operation, subcritical operation. So that was, of course, for research topics, for PhDs, what they did with the compressor and the system, it was very important. But I think the real development, what we did is, we started in the I think around 2002, we started to build the first semi-hermetic compressors. And in this time, it was also a development here in different countries in Europe, that they really started on field application with CO2. They were developed, for example, in Denmark and in other countries. They developed these booster systems, what we know today. And of course, they need the experiments with the different components, and also with the compressor we could build up in the first systems here in the different applications.
So that's really cool. So back in 1993 is when you first started developing compressor for CO2. That blows me away, right? And how far you came. So you started out in 93, 2002, you started building your semi-hermetic compressors. And so you've been testing those probably with different contractors, manufacturers, different systems. Would you have had, I guess, a lab with a test bench where you would try multiple compressors, testing the capacities, testing the superheats, the discharge temperatures back then in 2002?
In 2002, it was really early. We had also cooperations with some institutes, with some customers, of course. They built up some systems where they did their own tests, but we could also run, of course, some tests we could in-house. But of course, there was further development in 2006. I think when I came in 2007, 2008, we started more or less the second generation of semi-hermetic. So everything what we learned, of course, from the field applications, from our in-house and from the institution, where we could test the compressors. We built up, of course, the own lab, and today, of course, we have a huge possibility to test different compressor capacities, different size of compressors in our lab. We can do, of course, a lot of performance tests also for certification programs. What we have, for example, in Europe, where we do the ASACOM certification, so where you can see the performance data and share it with, for example, with competitors, to see that they can really confirm this data. So this is a certification process what we implemented here with the ASACOM. But we have also, of course, a lot of options to do a kind of stress tests for the compressors. So of course, what you mentioned, the superheat and different solubility issues, what is a little bit more challenging with CO2. That is something what we learned over the years, of course. There was a learning curve, of course, to see what happens in the field, what maybe you know, in the refrigeration, not always the ideal world is outside. So there happens something that they're coming back liquid, or maybe with the oil management system. This is something, a lot of topics what have to be learned with the CO2 systems, and what also, of course, what we could take this experience, what they did, and also what our customers did in the market, in the field, but also what we saw on our test benches, that we could improve the compressors in a way that we have today a very reliable and very efficient. This is, I think, the two focus what we have for compressors, that they can work in a efficient and reliable way, like you know it with synthetic refrigerants over the years. And yeah, this is something what we build up. Of course, also we have to consider the production side have to be developed, because they have to test compressors not only for 28 bar on the high pressure side, they have to test them on 150 bar on the high pressure side. So you need test benches for pressure tests, for leakage tests, and so on. So this is something what we implemented, of course, what we developed here, what we invest, of course, and it's still on the development side. We have the biggest part is in developing of new CO2 compressors, develop further the program what we have, and of course also develop the production on a more efficient way to producing compressors in higher numbers. What we see in the market is requested. Yeah.
Awesome. So what applications right now do you have your compressors in? Because I know supermarket's the big one globally. You know, these market applications. What other applications would your compressors be in for CO2 refrigeration?
Yeah. Yeah, I think this the supermarket is the most popular, and I think still, of course, from the total numbers, it's of course from compressor is the most important market here in Europe, but also in many other regions already. CO2 is very popular. But we have, of course, here in BOCK, we have two business units. What is we call it stationary and mobile. So we have not only the stationary, where all the retail business, the industrial application, standard commercial applications are included. We have also the mobile business, where we're focusing also on air conditioning of buses and railway, and also where we have transport applications for trucks and trailers. And also here we see CO2 is started in the stationary, of course, in the retail business, but we can see in many applications what we developed in the last years with the Star compressor, what you see behind me. This is a compressor development, what we focusing specific on the mobile and on the electrical buses. So electrical buses is a very big topic at the moment, mainly here in Europe, where we see the cities want to be more green, want to be more reduce their pollution and everything. So they want to they're focusing on electrical buses in the cities. And there we developed also with some customers specific solutions with CO2, which are not only responsible for the air conditioning of the bus, so they are also for the heat pump side, so for the heating. With the cold winter, you have to heat the passenger compartments, you have to heat the batteries and to cool the batteries so that they are always in the perfect temperature conditions. So these are the challenge, and this is, I think, where CO2 have a very strong advantages to other refrigerants. And this is what we see also in the supermarket, where not only for cooling, CO2 is interesting, also for heat recovery, of course. We can use that sometimes for free, or we have to add a little bit high pressure. We can use it as a heat pump, and then we can heat the market for free, more or less. We can also add air conditioning. We can use that, of course, also in industry processes, where we not only have refrigeration requests, where we have also heating requests. And this is, of course, a big benefit for CO2, I think.
Yeah, and that's exactly the way I feel, because when I started learning about it was just the booster system. And over the years of the last 7 years, I've learned that it's such an advantage this refrigerant has, especially for the heating side, getting into, maybe free heat from it, heat pumped, chillers. And I love this mobile application, because I didn't know it was in mobile application as much as we've talked about over the last couple of conversations we had. And that's very interesting, where you're using this compressor to not only cool the passenger, but now we're heating the passenger, heating the batteries. And I really like that. And that's new, it's different. And that's what's really cool about CO2.
Yes. I think that the challenge for mobile is always with the electrical buses, they want to have the distance, so the battery, how long you can drive with the battery, and this is of course when you have to heat your compartment, and you need a lot of electricity for the heating, and you can do that of course also separately with a heating system with a diesel, but then you are not completely 100% green energy. You have of course additional air pollution with your bus, and this combination is of course very interesting to see in which direction you can go to reduce your CO2 footprint for different applications, for example for buses, but of course this is also the focus in the stationary, to reduce the energy consumption and to reduce the costs, of course the running costs for your system in the end.
Awesome. So what type of capacity control would be on those compressors? Would you put a drive on that? How would they run? Would they just be standard fixed compressors, or how do you get the most efficiency out of those compressors on the mobile application?
I think for the mobile, it's the big benefit of the Star design. What you can see, it's only, we call it Star because it is like from an aircraft to star engine, where you see the pistons are arranged like a star. What you can see, it's here on top, you can see the different 6 pistons and 4 pistons design what we have. And of course, capacity control is for CO2 systems. If we are in a bus where we have maybe only the request for cooling the batteries, or where we have maybe only request for cooling the driver area, or where we have a stationary applications where we have the different requests for low temperature application, for medium temperature, of course for heat recovery. So there are a big load profile over the year for CO2 systems, particularly when they are responsible for the different loads what we have, and this is the topic. What our compressors are always, you can frequency control the compressors, and with the Star compressors we specific focus on that. We can go down to 13 hertz up to 75 hertz, so you have a really wide range of frequency control. Also for our semi-hermetics, normally you can go down to 30 or even to 20 hertz and up to 70 hertz. So to be very flexible in the adaptation of the load, because what we see is, of course, you normally design your system for the full load, but for CO2 it's very interesting to see what happens in the part load, which part load requests I have from the application side, and to really focusing, okay, can I run with the compressor in part load, or do I have too many start stops? Because this is of course for your system efficiency, for the balance and for the running behavior of the system not so helpful, and also for the compressor. Of course the compressors likes to run all the time, then you have a really stable suction pressure and no big fluctuations on the suction side, and then of course your complete system and the efficiency is going up, and it's also helpful for the reliability of the system and for the compressor, of course. Yeah. So all our compressors are frequency drive, and this is also a philosophy of BOCK. We're using always oil pumps in the compressor, from the smallest to the biggest compressor. So we have an oil pump, and the oil pump is lubricating the compressor in a very reliable, very efficient way, and this is old philosophy, but it's still valid, and what we focusing also in the CO2 compressors to have a good oil management system in the compressor to have a reliable compressor.
Yeah, we'll get into that. So for the semi-hermetics, you said it's 20 or 30 hertz to 70 hertz, because it'll probably range, because I've seen this with manufacturers. Some will do 20 hertz, some will do 30, depending on the compressor. For the Star compressor, again, what was the hertz range in that one?
13 to 75 hertz.
Is that 1.3?
1.3.
Yes. Wow, that is awesome. That is low. So inside those Star compressors, so these ones are horizontal compressors. For anyone who's listening on the podcast, it's a horizontal compressor, and the pistons look like a Star, just like Manuel said. Inside that compressor, is there an oil pump as well?
Yes. You cannot see it from outside, so I'm thinking there is no oil pump in, but there's still the BOCK philosophy in that we want to use an oil pump. And yeah, with the oil pump, of course, the oil pump is really interesting also when you're going down with the frequency. Of course, there are other technologies they also can use for piston compressors to lubricate it, of course. But what we see, the advantage is really when you're going down with the frequency, you still have a good lubrication to all moving parts of the compressor. And this is, I think, an important topic. And on the other side, of course, for the oil management in a CO2 compressor, specifically in CO2 compressor, is really important to understand that the lubrication or the solubility of CO2 and oil is very high. So it's important to understand to understand also maybe the challenge for CO2 compressors to build a CO2 compressor in a more reliable way. Is important to implement it a little bit more benefits of emergency running behaviors in the bearings, for example, in the conrods where we're using shell and bushers, and also a lot of optimizations in the different design of the piston pins and so on. This is always related to the situation that we have a higher solubility. And we also try to optimizing this oil management system in the compressor in the way that we try to separating the refrigerant from the oil sump. This is of course not completely possible, but as good as possible, because you can also optimizing to reduce your oil carryover, because the oil carryover gives you more headache also in the system side. You have to separate it again. You have to bring back the oil to the compressor. Your efficiency is going down in the heat exchanger, but also your efficiency in the compressor, because when you compress more oil, you have less refrigerant. And this is, of course, you can only work with the refrigerant to creating cooling capacity or heating capacity. So this is some optimizations, of course, what we doing specific with CO2 compressors. And I think this is also, in the end, the oil management system in a CO2 booster system is a very important topic to have a good idea and a good understanding of that it really work in a very reliable and efficient way.
Yeah, I love that, because that is so important to understand the differences between, because every compressor, you need superheat. That's why we have metering devices that we set at our evaporators. So we have superheat so we do not damage the compressors. And then with CO2, it's even more critical because there's this uniqueness of the solubility with the CO2 in the oil. For your transcritical or your medium temp compressors, what is the recommended superheat that you guys recommend for your compressors?
And that's a good question, because it is important to understand the system, what is behind, or what is the target from customer side, because of course we recommend sometimes higher superheat that we have in synthetical refrigerants or compressors, but in general, the trend is a little bit to reducing the superheat in CO2 systems, because you can push the efficiency of the system definitely. So you can use it, for example, with flooded medium temperature medium temperature evaporators. You can using liquid ejectors to taking the liquid from the suction side to bring it up. So there are of course different focus, and in the end, what is important for the compressor, that we have a reliable compressor, is always the solubility is depend on the pressure on the suction side and on the temperature side. And this is something what we can see in the Daniel plots, where we can see the viscosity of the oil is important, and the viscosity is influenced how much refrigerant we soluble in the oil, but it's also depend on the temperature, and the temperature, of course, in the oil sump is related what superheat I have and what discharge temperature I have. And of course, viscosity is always going down when the oil is too cold, but it's also going down when the oil is too hot. And in the end, you have to find a way how you can find a good way to balance this requests. So how to bring the efficiency of a system on a high level, so maybe reducing superheat, but what is important in the end is, of course, the compressor don't like liquid. This is still the case also with CO2. So you have to avoid, of course, that you get liquid into the compressor, and you have to avoid also that under specific conditions, maybe also not standard conditions where superheat is reduced, maybe when your expansion valve is maybe working not always on the ideal operation, that your compressors still survive. And this is something, of course, what we're testing also, that the compressors can handle a little bit liquid. You should avoid that in the system, but the compressors have to be designed, and this is our philosophy, to handle also such conditions where there may be a little bit more extreme conditions. So, but normally, of course, a standard recommendation is around 10 Kelvin superheat. Maybe even, of course, when you can use an internal heat exchanger, it's of course helpful to bring it up a little bit when you when you can benefit also from the efficiency side. But of course, when you can protecting the compressor in a very good way, that you coming into stress conditions and that you can avoid liquid or something or too low oil temperature, then you can even go down with the superheat. But it has to be balanced to see, okay, which protections I have for the compressor, liquid separators, the suction line, or internal heat exchanger, or really a very efficient system to work with the optimizations in the system, like ejectors or low superheat optimizations, which of course are in focus to bring the efficiency of the system high, but it has to be balanced with reliability and efficiency in a very good way to have both, yeah, in the end.
Yeah, no, and I totally agree with you. And this 10K or 18 degree Fahrenheit superheat is, what you guys recommend minimum, but there are cases where it can go a little bit lower. You could want it higher, and this is up to the manufacturer of that piece of equipment to test this stuff. As a technician, if you're out there, you want to be checking this and monitoring this and marking it down to see how cold is that refrigerant coming back. Because now, even though you have superheat with CO2, you still could be diluting that oil and you still could be causing bearing damage. Where when I was taught, when I first started talking about refrigeration, learning about refrigeration, well, if you got 5 degrees superheat and it doesn't go lower than that, well, you're probably not flooding back. But that's not true with newer glide refrigerants as well as CO2 refrigeration. And on another note is that not only do you have to monitor that superheat, you got to monitor that discharge temperature as well. So you want to keep a bit higher superheat, but you want to keep a lower discharge temperature. And what's really interesting, because I worked at Copeland in my previous career, and I always talked about superheat at the compressor and discharge temperature. But I noticed when I've talked to the European counterparts or talking to compressor manufacturers from Europe, you guys are very interested in the temperature of the oil. And this is even with synthetic refrigerants, where I never really dealt with that as much here in North America. Do you want to talk a little bit about the temperature of the oil and why you want to, and I know you kind of went over it, why you want to maintain and watch that temperature and what effects it has on the system when you get it too cold or too hot?
Yeah, it's I already mentioned it a little bit. It's of course the viscosity is in the end what we need for lubricating a compressor in an efficient way. And in the end, the influence is coming from the pressure. So when we go with CO2 in heat pump applications, for example, where it is also interesting for particularly for high water temperature heat pumps, this is CO2 a very interesting topic to heat up water from low temperatures to very high temperatures. There is CO2 a very perfect refrigerant, very interesting solution. But as higher we go with the suction pressure, as higher we reduce, or as stronger we are reducing the viscosity. And this is also the reason why we're changing when we go over 10 degree evaporating temperature. We changing to another or to a higher oil viscosity in the compressor. This is the focus why this have to be considered. And this is something, to be honest, it's not only for CO2, it's also what we see in hydrocarbons and also what we see with the A2L blends, what they're coming up in the market. So they all have higher solubility with the oil and have to be considered in the design of the compressor, but also, of course, which oil we can use and how we can optimize this in the compressor. But the temperature in the end is another influence, which is influencing the viscosity. And this is, of course, when oil is very high temperature, the viscosity is going down, but when the temperature is low, it's also going down, and it's even going down quicker than when the temperature is high. And this is, of course, in the end, the problem. It is not really oil temperature is nothing what we can see. It's not black and white. So it's a process, of course. When the temperature is going down, the viscosity will go down, and there will be a limit, of course, where we maybe cannot lubricating the compressor in an efficient way that it works under all conditions. And it's particularly also interesting when the viscosity is already low in the compressor and you get a little bit liquid back from the suction line, for example, that the viscosity is going down extremely fast. So it's always a topic to make a reliable system. You have to consider, of course, which temperature, which operating conditions we have, and what could be critical for the compressor and the lubrication of the compressor.
Yeah. What's your best recommendation on checking that temperature? Because you could get the pressure from the say the suction service valve. What's the best way to get the temperature? Do you at the bottom of the middle of your compressor? Is there a port on the BOCK compressors? I'm not really sure the best way to get that oil temperature.
You have the option, of course, to implementing a PT1000 sensor. That's an option what you can also order, where you can really implement it in your control system. But this is, of course, not really the standard. It's for many applications where we see it in heat pumps, for example. It's where there may be also extreme conditions, very high temperature on the discharge side. We have always the options to implementing temperatures in the oil sump or also on the discharge of the compressor to have an extra control option in the compressor. But of course, in the end, the most applications you have to consider is your operating conditions, is your different superheats are reliable for the system and for the compressor in the end. And I think this is, of course, the experience from the most rack builders. They know, okay, where I can run and where maybe are the limits. And in the end, the superheat, for example, particularly for the medium temperature compressor, is of course important because it is influenced not only from the medium temperature cabinets, and you cannot control it only with the expansion valve. So you have to consider that you have also influence from the low temperature side. So of course, your discharge from the subcritical compressor is going into your suction line of the medium temperature compressor and depend on the load on the low temperature side. For example, when you are running in the winter season, there is a lot of load from the LT side, and this is something what influencing your superheat and in the end the discharge gas of your medium temperature compressor. And then of course it could be that you want to have heat recovery for your medium temperature compressor. So in winter time you're running with high pressure in the transcritical area because there you can recover a lot of heat, and it's interesting to run as a heat pump compressor, so more or less. And this combination, of course, these are the interesting operating conditions where you should look in details. How is your design of the system? What happens when you have the different conditions? Because you should not only consider the operating, the high temperature operating in summer where you have the maximum load. So it can be also very interesting to consider part load situations or different situations where maybe only load from the LT is coming. It's also something, some applications where we see CO2 quite often is a LT storage or cold storage where only LT load is there. It makes also maybe sense to have a de-superheating of the discharge gas from the subcritical side, because otherwise you're only coming with so high temperature in the medium temperature compressor that maybe it's not able to run the compressor in higher summer days on high pressure side because there is too high discharge temperature. But the CO2 compressors are designed a little bit for higher, so we recommend it to, or we have a protection also in the compressor. It's possible to protect to measure or to protect discharge with a PTC sensor, for example. And this is normally the maximum temperature what we allow, this 160 degree on the high pressure side. So this is 20K higher, 20 Fahrenheit higher than we normally have with standard compressors. So there is even already an increase of temperature levels with CO2 only related to the higher thermodynamic and system design topics with CO2. Yeah.
So with the BOCK compressor, is there any type of electronics that you guys offer for this protection? So, or is there just the PT sensors inside the motors for protection? What kind of protection does the BOCK compressors have and options?
We have, of course, the standard is that we have a PDCs or 3 PDC sensors in the motor winding, so the motor protection with the motor protection tool, and we can add on this also the discharge protection. So to really have with a PTC sensor to protecting also the discharge side. And then, of course, you have the options to including the PD1000s, what normally is controlled by the system controller, where you have the different options. Also, what we have implemented now is also different capacity regulations, where we have also the options to control the discharge temperature with different sensors. So these are, of course, there are options which are available.
Yeah, and I think that's so important. I think the biggest one is that discharge protection. Like, not enough people check the discharge temperature out there. I've seen it many times, especially working for the compressor manufacturer, and these compressors come back. And you've seen it over the years. Lots of compressors come back. There's nothing wrong with them. Lots of compressors come back from system-related issues, not the compressor manufacturer issue. It's a system-related issue, and then multiple compressors come back from the same application, same install, 1, 2, 3, 4 failures because the problem's not being fixed. So big checks is that suction temperature, discharge temperature, suction pressure, discharge pressure, oil temperature. All these things need to be checked, especially with CO2 applications. One thing that I do like, and that I've been noticing here in North America anyways, when systems are installed, contractors are taking more time on the CO2 installs. So they're pulling better evacuations. They're using nitrogen or inert gas to blow in, because I'm sure you've seen many compressors come back over the years, and contamination from the systems cause the compressor to fail. And what I like about CO2 is that these systems are being installed at the way they're supposed to be installed, the way a regular system should be installed. Have you noticed that in Europe with the CO2 systems compared to the synthetics, or it's always been the same?
I think when you mentioned the dirt and also humidity and things, these are what we really learned at that time when CO2 go into the industrial application. So in big installations with long piping systems, so kilometer of pipings in a system, and of course quite often. Yeah, it's depend, of course, of the installation company. Sometimes there are subcontractors that do that in a very fast way, and of course it's difficult to do that in a maybe on a always on a clean level to have clean piping and protecting the oil from humidity in the system. And I think for such systems, what we learned is it's very important to working in a clean way, to protecting the oil, the ester oil, what is normally hygroscopic also, to protect this from water and from humidity, from the contact to the atmosphere. And I think the other topic is with CO2, the solubility of water in CO2, particularly when you go into low temperature applications. It's limited compared to synthetical. So you can also have, when there's too much water inside your system, you can have really free water. And this creates a lot of issues also in other parts of the system, from the expansion valve, filters, whatever. So they can create a lot of issues. But on the compressor side, of course, it is important to protecting the compressor from the dirt, because what is CO2 is a very good cleaner. So you will get all the dirt from the system back to your compressor in the end. And of course, we recommend always to have in such big systems, particularly a suction filter, and maybe also only for commissioning, or maybe to change that also regularly, to protecting the compressor. But what we also did is, for a longer time, particularly also the bigger compressors, that we including a suction filter in the compressor. This is something also what we really recommended to have, to do that also with some new technologies what we implementing this year, like permanent magnet motors, to bring the efficiency higher. But this is also a risk, of course, when you have magnetic motors. that you get dirt into these motors and creating troubles in the motor. So we're protecting the compressor with suction filter to avoid that dirt is coming into the compressor. And it's not only from the motor side, it's also, of course, for the complete drive gear of the compressor, of the valve plates. You don't want to have dirt in these areas where there are moving parts, where you can go down the efficiency, but also the reliability and the wear in the compressors. This is a risk, of course, with dirt, and also with humidity, because humidity together with high discharge temperatures is creating, of course, chemical reaction in the oil, and the aging of the oil is, of course, influenced with such
Yeah, no, and I totally agree with that. Like, the systems need to be clean, and take your time with it and understand it. Because I've talked with a few other manufacturers, and they recommend, after you do an install, you got to check that oil, and you should check it at 3 months, 6 months, 1 year, just to make sure that you're not having you got moisture in that system or humidity. You want to understand, because you lose one compressor, that pays for the oil, and oil's expensive. Like, POE oil is expensive, all the type of oil. I should ask you, what type of oil do you put, what's your recommended oil that you guys put in your compressors?
All the POE oil in standard. We have also the option to change to PHG oil, but normally our standard is the POE oil in CO2 system, in CO2 compressors. Yeah.
Yep. Okay. Fantastic. Okay, like there's a ton of knowledge that I've learned. My fingers are sore from writing, but this is great. I know that you said you have BOCK has multiple softwares, and you got some Excel spreadsheets that you can help show some people on how to select the compressors. Do you want to bring some of that up and talk about it?
Yes, we can. We have two softwares. What we have, we have a standard software where you can. It's called VAP software, VIP. You can find that on vip.bock.de. It's a free available software. Everybody can take a look in, do calculations. Maybe I can also show that. Yeah, it's a calculation software where you can find, of course, all different kind of compressors. You can search, of course, different languages wherever you are. You can also selecting different motor types, and yeah, it's very nice to implementing a single compressors to do a rough calculation, to get the information about the software, about the operating conditions, where you get the different capacities from the compressor side. But what is also you can see the different operating conditions for the compressor, where you can work with the compressors. You get, of course, a lot of information about the technical data, which sweat volumes you have, which electrical data you have for the compressors. And you get a lot of other informations, of course, also about drawings, spare parts. Also, you can download 3D models for designing some systems, to download their your step files, for example, to creating your software or your system. This is a program where you can find a lot of documentations, where you can find a lot of information about the compressors. When we consider CO2 systems, we designed also another software where you can really calculating booster systems. And this is, I think, important for booster systems because, the booster system, there is always different temperature levels where you have to consider.
Yep.
This is a software. Hopefully you can still see it.
Yeah, I can see it.
Where we design the complete software where you can implementing a rack system more or less. So you can also implement your data, what capacities you have, what operating conditions you have, which capacities you want to drive, and then you can selecting your compressors here. All the BOCK compressors, all the polynomials are in, all the the performance data are in. And this is you can do for different kind of systems. You can see you can calculating low temp, medium temp boosters. You can also calculating only medium temperature. You can also selecting parallel compression. You can also selecting heat recovery. Everything is possible. to design your system with the compressor configuration. You can also see the complete load in the end here, and you can get a lot of other informations about the operating conditions for the compressor. You can see the log speed PhD diagram, pressure enthalpy diagram, to see the different conditions, the different mass flows through the system. You can see here the PhD diagram, a flowchart for the system with the different operating conditions.
So Manuel, I don't see the flow chart, so I think maybe it's blown up a lot.
Okay, so it's lost the sharing. Maybe I have
No,
to share.
I see the sharing. It didn't go. I didn't see the flow chart or the BH diagram. That's
So
all.
maybe it's
There we go. Now I'm seeing it all now. Yeah. Wow. That looks awesome.
yeah. So when you're selecting the system, you can selecting here, and then you can also see when you change the system design here, we can see there is also the flow chart is
Oh
changed.
wow.
So you can see then you have only medium temperature, or you can selecting also without a parallel compressor. So you can calculate all the different configuration. And this is supporting you, of course, a little bit to design the system, to selecting the right compressor configuration, and to use maybe the parameters for further calculations of different components like heat exchanger with the heat exchanger manufacturer, of course, what you prefer, and also for the valve. So it's here, yeah, a helpful tool, and everybody who is interested to get this, I can send it to you, and you can use it for your daily work to calculate CO2 systems, to play around a little bit, to switch on off compressors, run subcritical, transcritical, to see what we discussed today, what it's important to have part load situation, to have full load situation, to have the different conditions, and to see what's going on in the different operating situations of a CO2 system. Yeah. So
Yeah, no, that's exactly what you need to do. Design any system. You don't want to just design it for the worst case scenario, because that worst case scenario is maybe 1% or 2% of the year. And so you got to see when it's at the part load, like you said earlier, low load, and then change it. And this software looks really cool. I'm definitely going to test it out and take a look at it. And so the first one is to get to it is just an online software where you can get all your documentations from BOCK, and that's vap.bock.de. So anyone who's listening, you can head there, and then you can get all the different types of compressors and look at all the different documentation BOCK has. And then this software here is not an online software. Is that correct?
Exactly. This is a Excel-based software, which is also, you can see there is a lot of alarms implemented to see where are my limits. So you get an alarm from the system side. You can also see, we have in the end also a summarize where you can see, okay, here are warnings, what I have to consider, maybe what I have to change in the system, or where I have to take care of the system when I do the design, and how, yeah, give some advices from the system side to how to design the system, and yeah, which configuration of the compressors are the best for my application.
That's huge for designers and engineers, like, because I haven't seen many softwares where it is explaining. It gets notes. It has a notes page where it's telling you, okay, this, and this you need to check. So that's really cool, and that's very helpful. Makes it easier for your customers to develop their equipment with your compressors. Something I didn't ask, because you're in Europe, and Europe has different voltages than in North America. What do you have any North American voltage compressors?
Yes, this is something, of course, good that you pointed out, because it's something what we are starting at the moment, and we will have available after summer this year. So in September, we will have an UL compressor range for the complete CO2 range what we have. So all our transcritical range from 5 to 90 kilowatt cooling capacity, and also for low temperature applications, the typical subcritical compressors, we will have for the UL, for the North American market available. And of course, here we're considering the standard voltage will be 460 volt, 60 hertz. And we have also the options to have different voltage options for these compressors as well, so that you can really give me a feedback when you are interested in to see what different voltage we have available. But the standard will be 460 hertz for the North American market. And yeah, this is something what we now pushing to come with the CO2 compressor into the North American market, and to see the different applications like we have here. I think the compressors are, yeah, of course, designed for all the applications like retail, like industrial, the bigger ones, like we have, yeah, from small 2 cylinders up to 6 cylinders with CO2. And what I mentioned, we pushing, of course, CO2 also, that we have now the smaller capacities, but we will also push it to bigger capacities to see what is possible. We have also some special versions for low temperature with high pressure versions to design also your system on the different pressure levels. So depend on your requests and your design philosophy of the system. We have, I think, the right compressor for that, and also for the North American market very soon. Yeah.
Awesome. So if people want to get a hold of you to talk about this, talk about BOCK compressor, where's the best place that people can get either a hold of you or BOCK and maybe get their questions to you?
Yeah, I think it's at the moment, of course, it's best to contact us here in Germany, but we are also building up, of course, a distribution channel in North America at the moment to really focusing on that market. This is our target, of course, for the next month. Yeah.
Awesome. Awesome. This has been great, Manuel. I've learned so much today. I know we connected on LinkedIn, so I'm sure if anybody wants to get a hold of Manuel, reach out to him on LinkedIn. Bach is on LinkedIn. It's easy to get to these softwares that he's showing today. Lots of great information, and this is how you get better at CO2. You come to events like this, you go and do some research afterwards, go find out, go take a look at them, go find out and check out their technical documents, check out these softwares. And this is how you learn. You build your knowledge, learning little things at a time, and continue to grow that knowledge, because I learned so much today. And it's continuing. And I know all the people on here have learned, and anybody listening is going to be learning a little bit more. So I want to thank you so much for taking the time to spend with us. I know we could probably talk another couple hours on compressors, because I love it.
It's a great pleasure. Thank you for having me here, and for all the people they listened for an hour to both of us to take the time. And of course, it's like Trevor already mentioned, when you have any question, please feel free to contact, to ask questions, whatever. No stupid questions, of course. And I'm very it's very nice to get feedback from the market side when you want to get experiments. We didn't talk about that, but we have also, of course, training systems here. We have training courses, webinars together also, for example, with Danfoss, to have not only the compressor in mind, also have also the complete system. What you saw today, it's very important for us that we have the compressor, but this is a part of the system and not the complete system, of course. And it's important for CO2, I think more important than for syntheticals, that we consider that as a complete system. And this is something what we want to focus in our trainings, and where everybody who is interested are welcome to.
Awesome. So that's good segue. Where would people find those trainings? Like, how do we get more people to find out about your trainings and when they happen?
When on our webpage, on our homepage, from this BOCK.de, so it's our webpage, and there is a category, it's training, we call it clever cool experts, and this is a area where you can find our training program, different trainings for CO2 mainly, and also for flammable refrigerants. We have trainings where you can feel free to take a look, and when you are interested, feel free to contact us. And
yeah, no, exactly. So yeah, when you go to their website, you just go to their main menu, and it's right there, clever cool plus cool experts. I just checked it out. Go check out their trainings. This is how you get better. You'll learn a bit more. I do have another question from someone. If someone wants that software, that design software, who's the best person to reach out to? An email address? Who do they contact if they want to get that engineering software that's not online?
It's of course, you can contact me. This is Manuel Fröschle with OE, not with the at BOCK.de. You can send me an email, and we will distribute the software to you.
Awesome. Yeah, and I'll throw that in the description of the podcast or the video, so you can easily reach out to get it because that software looks super cool. I'm excited to dive into that. Manuel, I want to thank you once again so much for taking the time to talk about CO2 refrigeration and your CO2 compressors, and we'll see everyone at the next CO2 Monday. Thank you, everyone.
Thank you for having me. Have a nice.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.